Hello everybody. Today we're doing 3.5. You will need a graphing calculator, so have that ready. Our first few examples are simply trying to figure out the domain and the range from a picture. So my first picture is a what? What is this picture? Parabola. What chapter did we learn about parabolas? Chapter 1. You got to start remembering the old days because the midterm's coming. So this is chapter 1. This is a parabola. So when I ask you what's the domain, you're looking at the x-axis, and you're thinking, where can this parabola travel on the x-axis? Can it go all the way up to infinity? Probably, yeah, because this continues all the way to the right. Can it go all the way to negative infinity? Yes, it can, because this branch goes all the way out to the left. So our domain is negative infinity through infinity. Or you could write that as all reals with your big R. Make sense? Let's talk range. So range is our y-axis. Infinity is up here on the y-axis. Negative infinity is down here on the y-axis. Can it go all the way down to negative infinity? No, because it touches here at 0 and it turns around and it heads back up. So what's the lowest value it can get to on the y-axis? 0. What's the highest value it can get to on the y-axis? So our range is 0 through infinity. Okay? Does that make sense? Domain is where the graph travels on the x-axis. And range is where it travels on the y-axis. And if you're looking at an equation, domain is what values can go in for x, and range is what values come out for y. Inputs and outputs. Make sense? Okay. Let's try what do we call this shape? A snake. It's coming from the equation y equals x cubed. Raise your hand if you think you know the domain. Charlie? Perfect, because this snake can travel all the way out to the left and all the way out to the right. So there's no restrictions on the traveling. And that's because we can put any value of x in for x. And then what about the range? Spencer? Same, right. So snakes are easy because it's all reals for both domain and range. What shape is this graph? I'm going to actually redraw it. It kind of looks like it's flatlining at 4. It's a square root graph. We've never actually seen a square root graph before, have we? So a square root graph starts at 0, 0, and it's kind of like one branch of a parabola, but a sideways parabola. So if you picture a sideways parabola, it's really only at the upper branch, and that's because you cannot square root negative numbers, and you can't get negative answers out when you're square rooting. All of our phones are in our book bags, right? Okay, so let's talk domain. Domain is our x-axis. What is the furthest to the left this graph can get on our x-axis? 0, good job. And then the furthest to the right is infinity. So it's 0 through infinity. I do want to remind you, you put that bracket on the 0, which means including 0. This graph actually can touch 0 because you can square root 0, so you do want to include it. And then range on the y-axis. The lowest we get on the y-axis is 0, but it can go up forever. It does start growing slower, but it keeps growing. So 0 through infinity is the same as the domain. The range and the domain are the same thing. That's not always the case that the domain and range match.
What is the square?
Alright, what is this next shape? It kind of looks like a sideways snake, doesn't it? It's because it's the inverse of x to the third. It's the cube root of x. So it's like the sideways snake looking thing. What would be your guess as far as the domain and range? Again, this is a bad picture. It doesn't flatline itself at 4. It does continue to grow.
Negative infinity to 0.
It doesn't stop at 0, though.
Oh, negative infinity to 0 infinity.
Yeah. On the x-axis, it goes all the way to the left, and it goes all the way to the right. So it's infinite domain. And range, same thing. It goes, this would continue down, this would continue up. So It's negative infinity to infinity for each. Or you can just write that all reals if that suits you better. This is how the pre-calc teachers want you to do it when you get to pre-calc. So. All right, so that covers domain and range. You already wrote down the domain and the range of both x squared and x cube, square root and cube root. I had a separate slide for it, but we don't need to write it down again. I do want you to be aware that these are called parent functions that we are now going to do things to. We're going to put numbers, and I'll give you an example. We're going to place numbers different places to change these graphs. So let's pretend I would put a 3 in front of the x squared, and then I would put a plus 5. That 3 would affect the graph by stretching it a bit. It would cause it to grow faster, so it would probably like grow up a lot bigger. And then that 5 would shift the graph up 5 units. So it would probably look like that.
Wait.
So that's where we're headed with this. We're shifting graphs and stretching and shrinking graphs.
If you put a number, wait, never mind. I'll let you get.
Are you talking about the number in here?
Yeah.
Yep, that would move it left and right. I feel like you did this last year probably. We'll get there. So what we're going to do is we're going to type this one in our calculator so that we can look at the values to determine what's happening. We can look at the graph to see the picture, and then we can answer the question of what it would be the domain, what would be the range. So before we even start, let's make a guess. What would you guess the shape of this would be? Because we know what the cube root looks like. It was a sideways snake, right? What's your guess? What would the 4 do to it? No guesses? Get it typed in then. So you type your 4 first. Then to get your cube root, just a refresher, it is math 4 and then x. So it's a sideways snake. That 4 stretch it out a little bit bigger than what it had been before. Your picture doesn't have to be absolutely perfect, but just do a rough sketch. If this was a quiz and you had to fill out the table, what would be your quickest way of doing that? Can you take me through the keystrokes? What buttons do I push? Second graph. So I'm not going to fill out all of these values. You definitely would want to round them either to the nearest tenth or nearest hundredth, but you could just fill out these values on your chart. So from like negative 5.77 all the way up to 5.77, you could fill it all out. On your quiz next week, you'll have to fill out the table. Okay? And to make sure you knew how to find the values. And then it's a sideways snake. What's our domain and range? All reals for both, or negative infinity. Scholarly way to say it. Negative infinity to infinity. All right, this one is going to be a 1/4 times the square root of x. Type it in, let's see what we're dealing with. The square root of x just had that one branch. We'll see how the 1/4 affects it. I like to play it safe, so I like putting that 1/4 in parentheses. I put it out front in parentheses, close my parentheses, and then I do my square root of x. What's it look like? Flat as a pancake, huh? It's almost like it got squished by an elephant. So that 1/4 caused it to grow a lot slower. And it still starts at 0, 0, but it's just real flat and growing very slowly. You can click table to kind of see the values, and I like to scroll down the table a bit sometimes, just to see where my values are going. Oh my! Is my calculator broke? Is my calculator broke? Why are there all those errors?
Yeah,
Not because they're small.
no, because they don't exist. It starts at 0.
Exactly. The negative values do not exist because if I would put a -5 in for x, you cannot square root a negative without getting an imaginary solution. So that's why it says error. So don't call me over during your quiz saying my calculator's broke, something's wrong. So it's literally going to be error. You can write error for the first few values, then it goes to 0, and then you can go ahead and fill out the rest. 0.25, 0.35, 0.43. Okay. And I was going to scroll a little bit just to show you. It keeps growing. 0.5, 0.55, 0.6, 0.66, 0.7, 0.75. So it keeps growing. It starts growing a bit slower when we get out here. See, look how slow it's growing out here. 1.141. See, it's growing very slow. I'm not even pushing any buttons. Look. My calculator's crazy. All right, so domain and range. What's the furthest left this graph ever goes on the x-axis? 0. And then it can go all the way to the right, so 0 through infinity is domain. And what about range? What's the lowest it can go on the y-axis? So our y-axis. 0 is the lowest it goes, and it can go up through infinity, even though it would take forever to get to infinity. It's growing so slow. All right, so let's get into some where we're shifting these left and right and up and down. Go ahead and jot down this part right here. I actually already put it on my board. These two are exactly the same, except one's a cube root and one's a square root. But each of these letters, A, H, and K, would affect the graph. It places it. So the A value is going to cause it to stretch or shrink. If it's a big number like 4, it stretches it out. If it's a small number like 1/4, it shrinks it down. We saw that in our last two examples. Now the H is the number that's going to slide it left and right. And it's a little tricky. I don't know if you remember back when we did parabolas. Remember how the minus sign was part of the formula? So if you saw a plus, it was actually a negative. And if you saw a negative, it was actually positive. Same exact thing. Let me give you an example. Let's say my graph was the square root of x minus 3 plus 2. That 3 would actually move the graph to the right because the minus sign is part of the formula. Isn't that weird? So what if it had been x plus 3? It would go left 3, right. So we're just going to keep that in mind. And then the k value would slide the graph up and down. So this particular example I wrote up here would slide up from where it used to live at 0, 0. So I have it up on my board. You kind of look, it's like our formula of the day, kind of. I'll keep it up there. I don't have a song. You could make one, though, and put it on YouTube, and I'll give you a scholar pass if it's good, if it's scholarly. I've had students do that before, make songs. Quadratic formula song, they made a song. The logarithmic song, they made a song. Ready? All right, so let's talk about this one before we type it in. How would the -2 affect the graph?
Flip it.
Yes, the negative actually flips it upside down. So square root graphs, the parent function of the square root graph would look like this. It's going to get flipped upside down, so it'll probably be down here. And then how would the 2 affect it? Stretch it a little bit. What about the 3? 3 to the right. So this guy who used to be at 0, 0 would move 3 to the right. And then what about the 2? 2 up. So it's probably, my new guy is going to be here at 3, 2. It's going to be downwards. But let's graph it and see. So that's us just thinking about what could happen, but let's see in the calculator. -2 out front. We're using a square root, so just use the normal square root, not a cube root. When you type in your x minus 3, how do you get out from underneath that radical? Hit the right arrow. I don't know if the down arrow works. The right arrow will. Oh, okay. She's different. Oh gosh, so yours, I think you figured it out. You need parentheses on one part. So you're going to have to close these parentheses off right here. Like that. So that the +2 is not part of the graph. I forgot to mention if you have the older calculator, that little hint. There it is. So my old point that used to be at 0, 0 is now at 3, 2. I'm going to label that because that's going to be important for our domain and range. and then it's kind of going downward like this. It wasn't the best drawing because my board's not super aligned well, but it gives you an idea. Everybody's calculator worked okay. I don't need to fix anybody's windows or the Zooms. Zoom 6 if it's not working properly. All right, let's talk domain and range. A little bit tricky because of how this has shifted. Let's talk domain first, our x-axis. What's the furthest to the left this graph gets on the x-axis? Right here at 3, right? So I'm going to write that number down first. And then can it go all the way to infinity? Yeah. Sure can. So 3 through infinity is our domain. All right, we'll talk range, our y-axis. How far down can it go on the y-axis? The highest it can go is 2, but how far down can it go? Negative infinity. I always start with my lowest number it can get to, so negative infinity is the lowest number it can get to, and 2 is the highest number it can get to. You always want to go lowest to highest, lowest to highest. The bracket means include. Oh, and normally you don't use a bracket on your infinity. That was a mistake.
Come on.
Yeah. You can pause the video and come with your calculator. Never mind? Okay. We only have one more. Awesome. Well, it's 10:59. Oh my. Pause this video. All right, our last slide. How would that 3 affect our graph? Stretch it a bit. Yep. How would that 4 affect the graph? Probably going to be left 4, because remember the minus sign is part of the formula. So what actually was happening that we're not seeing is that situation. And then how would the -1 affect the graph? Down 1. So it's going to go left and down from where it normally is centered, and it's normally centered at 0, 0. Let's type it in. This time it's cube root, so grab your cube root in your math menu. So 3, math, 4 will get you that cubed root. X plus 4, click your right arrow, and then -1. Oh, x minus -4 is what is happening, but we're seeing it. Equivalent.
Okay.
Nope. All right, graph it. It used to be centered at 0, 0. Now it's centered at -4, -1, and it's that sideways snake shape again. Which the domain and range is so easy for snakes. Don't mess up your domain and range on snakes. What is our domain and range on snakes? All real numbers or both, or negative infinity to infinity. All right, so the homework tonight is the back side of the 3.4, 3.5 worksheet that you already have. I'm going to say that on the video for people who want that.